Hello, this video is on section 3.2, which is titled Solving Systems Algebraically. And we're still dealing with some systems of equations that we dealt with in the last section, except now the learning target is to solve linear systems algebraically. So again, a linear system is two or more equations. And then there's two different ways specifically that I want to touch base on and how to solve them without graphing the lines and finding the intersecting points. And the first way is called substitution. And substitution is if you take one of your equations and you solve for one of the variables in that equation by getting it by itself, which you'll be familiar with solving for y, getting y by itself, what we talked about in the last section. And then whatever you get that's on the other side of that, you plug that into the variable of the other equation and then solve to get the variable for that one, and then you substitute it back into it again. So for example, let's say you have the equation 2x plus 4y equals 6 for the first one, and the second one, let's just make it x minus y equals 3. This is completely hypothetical. I'm not sure if there is a solution to this. But so the easiest thing you would want to do for substitution is getting one of the equations, one of the variables by itself. And the least math involved is to solve for this x by adding y to both sides, so getting x equals y plus 3. And then you take whatever your x is equal to in this equation and plug it into the value of the x of your other one. So this equation now reads 2 times y plus 3 plus 4y equals 6, and then going down by distributing what's outside that parentheses and then solving for the y for this one. Keep going down and down and you get a value for y, and then whatever you get for this you plug back into the y for this one, and that's substitution. And it takes a lot of work and a lot of algebraic skills in order to solve for this, but I do think it's good practice, and it's a good way to check and make sure that, oh, if it doesn't work into one equation, then you plug it into the other, and you have a lot of options on which equation to start with. I could have solved for this x here, that y there, this x here, or that y there, but the easiest one that I chose is to solve for this x first. There's 4 different options you have at the start if you have 2 variables and 2 equations. Now the other one I want to talk about is elimination. And elimination is if you combine the 2 equations together and you add the like terms up vertically, you're going to end up canceling one of the variables or eliminating it from both of those equations, and then you solve from there. So for example, if we have, let's keep the same first equation, 2x plus 4y equals 6, and then let's say our new equation is negative 2x plus 2y equals 3, whatever. Now a way you can eliminate this is if you add up all of the terms vertically and see if something cancels out. So adding these two up, 2x minus 2x gives me 0 x's, or they cancel out. 4y plus 2y gives me 6y, and 6 plus 3 gives me 9. Then you go through solve for y, and in this case you will get the fraction 3/2, and then you take that value of y and you can plug it into either this y here or this y here. With systems of equations, you have a lot of different options to solve for them. Like substitution, there's 4 different ways to start out, and then even from there going into which one you can plug in works. And elimination, you won't use as often because it doesn't always work right away. You may have to find some factors, but with practice you may be able to see, oh, I think if I multiply a number to this equation then it'll work here. But we'll go through some examples in class and kind of perfecting the ways you can solve without plugging it into the graphing calculator. Alright, thank you.